Hello guys, welcome to next class of sampling theory is nothing but testing up hypothesis. Before I to consider testing up hypothesis, first I have to consider one of the important theorem. But here I'm considering only the statement. If you very much interest to the proof, you go through Walpole textbook or Miller and Johnson textbook, they derived. But here I'm not going to explain how we get the proof. I don't want in this course only I required a central limit theorem or formula. Now for my convenience, central limit theorem I am going to consider CLT, central limit theorem. The central limit theorem is one of the most important one of the what actually one of the most important result in the probability theory. This is one of the most important formula in the probability theory. It states that under certain conditions the sum of a large number of random variables is approximately normal. The formula for central limit theorem is Z equals T minus E of T divided by SC of T, where T is a statistic. Statistic means nothing but variance, proportion, mean or standard deviation of the sample is nothing but statistic. The central limit theorem is also simplify our computation significantly. Means actually this theorem is one of the important formula. See, before I'm going to start, one thing I forgotten to inform. Now there are sample, there are two types. One is a large sample, another is a small sample. I told in my previous videos, whenever size of the sample is greater than or equal to 30, we treat it as a large sample. Whenever the size of the sample is less than 30, we treat it as a small sample. Now I am going to explaining testing of hypothesis generally. After that, we are consider a problem based on large sample. Once you complete large sample, we are moving to the small sample. Keep in mind, size of the sample less than 30 is a small sample. Size of the sample is greater than or equal to 30, then treated as a large sample. This, see, the one thing we are going to do while applying testing of hypothesis, the suppose size of the given sample is a large sample, even though they are not mentioned the distribution is a normal, we are going to assume or we are going to treat it the given distribution is a normally distributed. It's normally distributed, but you can't use the same steps what you already studied normal distribution, because here we are creating a sample from the population. Therefore we are going to take some modified formula what you convert x to z in the normal distribution. This is the first point in the normal distribution. First you convert the random variable x into standard normal variate, but you can't use same original formula. We are going to use the formula is z is equal to t minus e of t divided by sc of t. Sc means standard error in the corresponding statistic. Statistic means mean, median, variance or proportion of the sample. That's why the central limit theorem is one of the most important result in what actually probability theory. It states that under certain conditions the sum of the large number of random variables is approximately treated as a what normal. Even though they are not mentioned, whenever the sample size is large, we treat it as a normal. Once you treat it as a normal, what's the first step? I have to convert the random variable x in terms of standard normal variate. There we are going to use central limit theorem is t minus e of t divided by c of t. You can't use the original normal distribution formula. We are consider the sample is a normally. Now we are using this. SC means standard error in the corresponding statistic. Statistic means mean, variance, standard deviation or proportion of the sample. CLT is also simplify our computation significantly. Means if you want to take a decision, I have to find out analytically from the given data of the value. Finding a value, there we are using formula is CLT. That's why this is also simplify our computation significantly. While doing a problem, while further my videos I'm going to explain, just you remember what meaning of CLT, where they're going to use. The next come to the testing of hypothesis. If you want to solve problem by using testing of hypothesis, we have to follow some steps. Hypothesis testing begins with an assumption called a hypothesis. If we want to solve problem by using testing hypothesis, first step is we are going to do the assumption. That we take, that assumption how to take, that we take about a population parameter. Yeah, if you want to go for testing of hypothesis, what's the first step? We have to do the assumption. How to take assumption? We are going to take assumption based on probability, based on population parameter, based on population mean, variance, standard deviation, or what about proportion. See, keep in mind, if you want to solve problem by using testing of hypothesis, what's the first step is we have to do the assumption. How to do the assumption? We are taking assumption about the population parameter. Hypothesis is an assumption made as a basis for reasoning. The conventional approach to hypothesis testing is not to construct a single hypothesis about the population parameter, but rather than to set up two different hypotheses. Say one is a null hypothesis, another one is a alternative hypothesis. The meaning is, see, while I told hypothesis means first we have to do the assumption. How to do the assumption? We have to do the assumption based on the population parameter. You can't take one assumption. Suppose you have to take one assumption, that is not more effective. We are going to take how many assumptions? Two assumptions. One assumption is called null hypothesis, another assumption is called alternative hypothesis. If you want to open any textbook while solving a problem by using testing hypothesis, that's why they consider two assumptions. One is null hypothesis, another one is alternative hypothesis. Then suppose you have two assumptions, then easy to proceed. So that one hypothesis accepted, one assumption is accepted means another assumption is where we are going to reject it. Then easy to proceed. Because of that, while doing any problem by using testing hypothesis, we are going to do the assumption. How to do the assumption? We are doing assumption based on parameter of the population. But you are not expecting only one assumption. We are going to take how many assumption? Two assumption. Once you take two assumption, then easy to accept one accept, then easy to reject the other one. Now, I told what are the two assumptions just 1 minute before. Null hypothesis, another one is alternative hypothesis. Now I am going to explain what's the meaning of null hypothesis. When you are talking about null hypothesis, that is always denoted by capital H suffix 0. That is a standard notation. Hypothesis of no difference is called null hypothesis and is denoted by H naught. That is a standard notation. Once you write H naught, that is denoted by, that is denote what actually? Null hypothesis. Hypothesis of no difference is called null hypothesis and is denoted by H naught. Null hypothesis is the hypothesis which is tested for possible rejection under the assumption that it is true. Under the assumption that it is true. Under the assumption that it is true. It is very useful tool in testing of significance. Again, I am go back to the null hypothesis. Hypothesis of no difference is called null hypothesis. Hypothesis of no difference is called null hypothesis and is denoted by H naught. Null hypothesis is the hypothesis which is tested for possible rejection under the assumption it is true. It is very useful tool in testing of significance. For example, if you want to find out whether the special classes after the school hours has benefited the students or not. Usually it's benefited the student, even though it's benefited, but what we shall set up null hypothesis. There is no benefited after you conducting a special extra class for the after the class hours. That's the way we are going to take H naught. I think everyone is clear how to pick the H naught. If we want to find out whether the special class after the school hours has benefited the students or not, we shall set up a null hypothesis. Special classes after the school hours has not benefited the student. Means we are going to take there is no difference for the original to that. Original means only conducting classes. Update means after the regular classes we are going to conduct special class. Once you conduct special classes, is there any improvement? Even though they have an improvement, we are telling there is no. That is the beauty of H naught. Special class after the school hours is not benefited the students, because just now we told H naught is always you are taking assumption is no difference. Even though I have to do the update, actually you have a extra special class, you have a the benefit, but we are telling that in H naught after the school hours has not benefited the student. I think it's clear. Now always you are taking H naught in the, there is no difference even though you are doing any update. That is the assumption for H naught. Alternative hypothesis is nothing but opposite of H naught. Any hypothesis which is complementary to the null hypothesis is called an alternative hypothesis and is denoted by H1. For example, here we want to test the null hypothesis that the population has a specified mean, say mu naught. Yeah, now I'm going to take, there is no difference between the population mean and mu naught. I told already H naught always you are taking in the form of there is no difference. Means you are taking in the form of equality. There is no difference. Even though have a difference, you are telling there is no difference. Now, what's a question actually? If you want to test the null hypothesis that the population has a specified mean, say mu naught. Yeah, you want to test whether the mu is equal to mu naught. Test the null hypothesis that population has a specified mu naught. Step 1, null hypothesis H naught is mu is equal to mu naught. But complementary of H naught is what? Three possibility. Mu is not equal to mu naught, mu is greater than mu naught, mu is less than mu naught. Therefore, we have to take any one of these possibilities. Suppose we have to take mu is not equal to mu naught, we telling that we are going to go for two tail test. See, while solving a problem in testing hypothesis, we have to decide based on alternative hypothesis, you go for one tail or two tail. See, once you have taken mu is not equal to mu naught, either maybe have a negative or maybe a positive, therefore we are go for two tail test. Whenever I take greater than, if that comes in positive value, is a right tail. Whenever I have to take less than, we are go for left tail. Just keep in mind right tail, left tail and two tail. I'm going to explain in further classes in detail. But the thing is, the taking one tail, two tail, this is not equal means two tail. Either you go for left or right. Therefore, I consider both two tail problem. Greater than means right tail, less than means left, therefore left tail. Therefore, maybe we'll go for any one of these three and to decide based on what we have taken assumption for alternative. Therefore, taking assumption of H naught and H1 is a control entire the problem for the testing of hypothesis. Therefore, before going to take H naught H1, please take care carefully to take assumption for H naught and H1. Once again, I'm going to repeat while taking H naught. Now we are going to assume, we are going to take assumption, we are usually going to take assumption from the problem, from what they given data, we are telling that there is no difference, just like mu is equal to mu naught. While come to the alternative, we are going to take not equal, greater than or less than depending upon what they expecting the problem. Based on that, I go for two tail or one tail problem. I am going to explain in my further classes what's a two tail, one tail. Thank you very much for listening. Thank you. Bye.